Hey, good afternoon. How's everybody?
Good, Professor. Good afternoon. Guys.
How are you, Yingyu? How are you, Ophelia? Abraham? How's everybody else?
Good afternoon, Professor.
Good afternoon, Mohammed. We're having quite a humid day today. I mean, since yesterday, it's been very humid. Um, Hope you guys are all, doing well. I mean, health-wise, um, it's a typical, summer day, um, hot and humid. How are you, Ophelia? Now, I hope you guys have noticed that. I mean, there has been several emails about whenever I sent out a notification, it goes out to you by email, but it's also posted in the announcements. So let me quickly check. So let's share my screen, and then okay. So this one is okay. This one is working. Sharing my screen. So I'll take you to first. Let me check. Let me check today's forum first to make sure. So we have just 1 week left. This this means, okay, we have like 15 people currently logged in, and this means for you and for me, for all of us, this is going to be a very, highly stressful and stressful crunch time. Why? Because we have to get a lot of things done. Now, the midterm instruction went out today, and it's going to be start on this Friday, and ends on Sunday. I mean, that's the window. I mean, you have 3 day window. You have 120 minutes. You have to pick 120 minutes during that 3 day window. Okay, and it's weekend, so that's why I picked the. But we don't have the luxury of weekend anymore after this weekend. And also, you must have got this email. Get a head start. Okay, absolutely, it's absolutely important. It's absolutely imperative. Why? Some people procrastinated to the procrastinated until the end. Then problem happens. Then in panic they send me an email. But at the last minute, if you send me an email at the last minute, there's nothing I can do. Okay, I cannot fix that. I mean, if it is, it's not me. I mean, it may have to be fixed by the BMCC, technology team. But no, most of the times it's not that. It's not it. It's usually, your internet. Usually the reason is, I was doing my work and I was doing my exam. Suddenly, I got shut down. I got, kicked out of the exam, out of the blackboard and blah blah. It's most of the times, the connectivity, internet connectivity issue, or you may have been timed out for whatever reason. But look, if it is connectivity issue or whatever technical problem it may be, I can fix it if I have plenty of time. You understand? I can fix it by resetting your exam, resetting, so you can start anew. But I, if I if I have 1 or 2 days left, I can do that, right? I can discover your email if you have a problem. And I've been telling you all this time that if you send it to my BMCC email, it's useless because it's not going to be discovered. right? I've been telling you somehow the whatever email that is related to um, Blackboard, or even CUNY, business, the emails from CUNY, the mail server, I think automatically just considers that as whenever it has like a long list of recipients or um, CC, the carbon copy, recipients. Even if you are sending it to me, but originally, if that was, mass email, then, and you are replying to that email, think about it. It was mass emailed to everyone. And then somehow, mail server, BMCC mail server, automatically considers it as spam mail. So it sends it to junk mail. And sometimes, although I try to go through the junk mail, screen, the filter out good mails from, junk mail, that sometimes cannot guarantee that your email can be spared. And even if and they get periodically deleted. So use your good sense, be sensible. I gave you the email, my, Yahoo Mail. You send it to Yahoo Mail, please. Okay? And then send it at least one day ahead, with one day left at least. If you send it on Sunday, and especially at the last minute, close to 11:59 p.m. I mean, if you send it at 11 p.m., do you think I would be awake and watching, just watching watching my email? I don't watch my email. I don't check my email 24 hours round the clock. I check my emails at certain point, like noon or 3 p.m. But look, if you run into that kind of problem, it better be on Friday or on Saturday, because at least then there will be time enough for me to respond to that emergency call. You understand? If you send it at like 10 p.m. So that's why if you send it at 10 p.m. on the last day, there's no response time. I won't be watching my emails at that time. I mean, 11 p.m. most likely I would be asleep. And it's too late then. And some people, this is so insensible. I mean, people with any rational mind and sensibility would not do this. But in the past, there were students who they were doing the exams at the last minute. And then they got into this, of course, if you started, and when I look at their, record, the access, record, they access the exam at like 11 p.m. or 11:30 p.m. That's obviously a nonsense, because this is, I gave you 120 minutes. You have 120 minutes. So that means, it will take, at least you got to start. If it takes 2 hours, of course, most of you will be able to do it within, anywhere between 60 minutes to 90 minutes. But, you got to get started at least 2 hours ahead before the deadline, right? But some people just start at, they get started at, they start at 11:30, thinking that they can do it within 30 minutes. And then once it is 11:59, it will automatically shut down. So you're in the middle of, you're in progress, you're in the middle of it, and then it kicks you out, and then you're in panic. You send email at 11:59. You have only yourself to blame if that happened to you. You understand? You send me email at 11:59. There, it's too late. There's no. I don't have any response. There's no response time. I can't respond to that at the last minute, right? There's nothing I can do. And the people who think that they could do it in 30 minutes, unless you're a genius, right? It's never gonna happen. You can't do it within 30 minutes. It will even take 30 minutes to read it, only just to read it, without even thinking about about the solution. Just to read the problems, it would take 30 minutes. And then if you get kicked out, of course it will automatically auto submit at 11:59. So it will shut down. And then that's it. Whose fault is that? It's your fault if you started at 11:30. And I've been telling you all this time, get a head start. It's going to open from Friday, so you get a head start. Starting on Friday. And if you run into any technical issue, then you email me. I can discover your email, and I can reset your exam, and the problem can be solved, and you will have we can have it can be resolved. And even by Saturday, if you send me email, if you run into these technical issues on Saturday, I can fix it. Your email will be discovered, and I can reset your exam. But if you do it like after 12 p.m. Sunday, then the chances are your email won't be discovered and your problem won't be resolved. And if you're sending it close to 10 after 10 p.m. After you don't do that after 10 p.m. Anybody who tries to do it after 10 p.m. Sunday and run into any problem, there will be no there will be no response to such an email. Okay? So give yourself plenty of time, get a head start, and if you don't procrastinate it until the last minute. Okay? You have only yourself to blame if you run into technical issue or if you get timed out. Okay? Alrighty, so that's it. And after that, you have quiz 2, and because we have to have quiz 2 and final within the span of just 1 week, the quiz 2 will become the instruction will go out on Saturday the 14th, and it will be available from the Sunday the 15th, and it will be due Tuesday the 17th. Final instruction will go out, accordingly. Everything will have to be done by the 19th, because the 19th is the last day of class. 19th is the last day of class, and think about it. Actually, the exam the final should be done by 20th. So I think I should do that. It should be from the 18th, because I should give 3-day window. So it should be from 18th. Why? I have only the registrar. It's always a rule. They want the grade to be submitted. They want the grades to be submitted within 48 hours. 48 hours. And think about it. 19th is the last day. 48 hours is the 21st, Saturday. So that means I have to, collect the exam must be finished by 20th. I must collect the data and then grade, right? And grade report should be submitted to registrar by the 21st. So that's 48 hours I have, mere 48 hours. So I have to get the final data in by Friday. You understand? So listen, I've been telling you, I cannot, when I'm looking at this, this is what I can see. I can't see, I'll have to switch to another window. So it sounds like there's something, you're typing into the chat box. I can't see it right now. So it's going to be a crunch time, right? And everybody should be, prepared for that. You should have a fully, combat ready. Okay, you should be fully combat ready. So anyway, so there was a okay. Marielle, I was just talking about that quiz 2. I'm sharing this screen. I'm sharing my, and I can't see that, while I'm looking at this, I can't see this. I have to switch. So why don't you just speak up, right? And I was, sharing this screen so you could see quiz 2 is gonna go out on, this is instruction will go out on August 14th, but it will start from Sunday the 15th, and we'll have to end on the 17th. And the final will then, have to start on the 18th and must, end on the by the 20th. That's the window. Those are the windows for quiz and the final. So you must, of course, it's going to be like 120 minutes. I will, so this one, 120 minutes, final, maybe, final also 120 minutes. So, just, it's obvious, the last day of class is the 19th. So final will have to be, on the 19th or on the 20th. I mean, and I give you 3-day window always, so you pick the best time, best 120 minutes. Okay. Alrighty. So.
I'm sorry,
any
Professor.
questions? Yeah. Go ahead.
No, yeah, I wanted to say I'm sorry because I was in the hospital just now with my daughter. She was in the room and the doctor was talking to me, so I had stepped out. So they were talking to me about when my daughter was getting surgery. So.
Okay, I'm sorry to hear that, but I'm sorry to hear that. But that's Marielle, right? Look.
Yes.
Okay, so you couldn't speak up. That's fine. But let's see. Let's go to without further ado, because it's already 6:22. So let's get to today's. We got. Actually, I've been telling you all this time that this is what we do in the Collaborate session is not the original lecture. Original lecture is it goes by all these schedules. As of today, the bond valuation, you should have finished the bond. You should have this. You should be here. Okay, bond valuation. You should be here. And I don't know why, no, this is wrong. This cannot be. Let me, this is not your class. It was, spring class, but, still, this should have been available already. But this will give you, this will serve you very well, but this is, you don't have to, if you don't have time, you don't have to watch this, but this is a discussion about what happened, earlier this year, Robinhood, what's that, GameStop, but you don't have to. So anyway, you should be caught up all the way to this, right? Bond valuation 5 as of today. But I need to have the collaborate session is a way to check if your understanding is solid, and because it takes so much time, we are so behind. So yesterday, so is the Excel file, is it what you're looking at, the Excel file? Is that what you're looking at? Tell me.
Yes.
Because I'm sharing my screen. Okay, thank you. So yesterday, so we were, we didn't have, I mean, it takes so much time to explain why we use natural log, why we have to use natural log to solve for n, right? Because out of 4 variables, because we have principal, interest rate, and future value, and depending on which one is the unknown, we need to tweak the we'll need to tweak the base formula, which is this. We'll need to tweak that to solve for the unknown, and we've covered it all the way up to the rate. If the rate is unknown, and that's nothing difficult because we already know. We talked about geometric average, and then at the beginning, and then to solve for n, you have to understand what is natural log, and to understand what is natural log, you must understand what is the Euler's number, and that had to be, that couldn't be crammed into 2 hours. So I, referred you back to the recordings, of the video, the recordings of the collaborate session from another class. So I don't think you could have, and I told you to finish it, right? But I don't know whether you had time to, because these are like 8 hours. Each one of them are like 2 hours, so they are like 8 hours. But whatever, yesterday was August 10th, so you should have watched at least these 2, and then that's 4 hours already. Today it's this, and actually you should watch this too, but that's 4 hours. It takes 4 hours. So I want you to okay. Now, if possible, watch this later after the this class is over, because I want to actually do demonstrate the solutions, right? So assuming that you have watched the video yesterday, videos about how, so using natural log, we derive from this base formula, through going through these steps, we come to this outcome. So this is the formula for solving for n, okay? And did we Okay. So I believe we did this yesterday. We did, or was it the day before yesterday? We did this example. That was the day before yesterday. So um, let's find n. So in this case, in this example, the same example, this time, you know the prevailing market rate. The prevailing market rate is 24.57%. So if you want to grow your 10K to 30K, when the market rate is like this, how many years will it take? Now, this time, T is N, right? T is, 5 years is exactly N because, compounding frequency is just once a year. It's annual compounding, right? It's just annual compounding. Uh, so we can simply, using the formula, and the formula is natural log. It doesn't have to be, capitalized. It will automatically capitalize. Natural log of the ratio between the two. Okay, over that divided by natural log of 1 plus r. Again, APR is exactly the R, periodic rate in this case, because the compounding frequency is just 1, right? So if you do that, then we get that, 5 years. Now, of course, we started out from this scenario, so this input data, so we should get the same thing. Now, what's it going to be? And you know that when compounding is more than once a year, as the compounding frequency increases, you get greater the future value. In this case, you might wonder, why isn't it greater? Look, instead, I mean, future value is already given, right? We know we have the target future value. We're not solving for future value. I mean, so since future value and principal are the same, then it will have the rate should be smaller. That means with the smaller rate, you can get to the same future value. I mean, if it was same 2457, then the future value must have been greater, right? Also, this means, with the smaller rate, with more compounding, the smaller rate can still take you to the same target future value, right? Now, at this time, we will need to do it. We will need to use, we will need to make adjustment inside the formula. So first of all, so it's going to be natural log of future value over, right? And then present value or principal divided by natural log of 1 plus r. But what is r? Our periodic rate is, because this is annual, then quarter rate must be this divided by 4, and that 4 is in here in column D, so that's in D21. Okay, and then voila. And you see, once we do this, then that's not the final answer. Why? Because look, what we are solving for is actually using the periodic rate. Because we are using the periodic rate, the result will be actually how many periods, actual quarters, actual number of quarters. So it's going to be 20 quarters. We're going to get 20. There you go, we get 20. So this is not year, right? Look, the label says time is in years, so this is wrong. You cannot give this answer because this is like 20 years. This is, you're telling that it takes 20 years. No, but we know it is 20 quarters. 20 quarters. So then how do you convert this into 20 quarters? Of course,
Divided by 4.
we divide it by, yeah, yes, yes. And who said that?
Sophia.
Okay, Safia. Okay, Sophia. I mean, this is not a big deal, but at least, nobody was, saying that, but you said that. You had the sometimes there was you had the nerve to say that. No, you had the initiative, right? You had the initiative to say that. It's important. Some people there should be more people with initiatives and proactiveness, right? Then just stay uh, uh, then stay behind. All right. I didn't, complete it. So I gotta, divide it by 4. But the 4 is you don't hard code it. This is very important because if you hard code it, meaning if you input number 4 there manually, then it cannot be recycled. It cannot be reused, right? If you soft code it, meaning, I enter D21 there, and when these things change, when the input data changes, this result, the result will automatically adapt because nothing was hard coded, right? When these numbers change, if you have a different scenario, as the input data changes, it will automatically adapt. You can, replicate this model over and over again, right? Right? That's the benefit of soft coding. Now, just one more. So I want you to do this with me because that's why, I'm always, I always check if you have this file in front of you. Do you all have this file in front of you? You must have it in front of you. Huh? You must have this file in front of you. Okay, good. You have this file. So you got to do this with me. Okay. So the next one, I'm gonna make it equal to this, so that we would have the same. That will confirm the same result, right? So here, in this one, this is the unknown. In this one, this is the unknown. And once we have, so you understand this is the same. Why do I have so many pens? Is it this one? Okay. Oh, so that wasn't it. That wasn't it. Okay. So here, I'm gonna put the. Oh, why is it? Okay. Just the board. Take borderline then. Okay, so that's it. So here it will be a lot, the same model, but with R and M, additional columns for R and M. It's going to be a lot easier. So here it's simple. R, then all we need to do is FB over key, right? Raised to 1 over n. N is in F25. I can't click it in because the formula was, overlapping, hanging above that cell. So we'll just have to manually enter F25, and then that's it. And we get, we got this. That's quarterly rate. That's quarterly rate, right? So how do we turn it into annual rate? Multiply by 4, right? Then we got that. Okay. And then since it is already, when this is found, then it is automatically entered there. Now we need to find years. In other words, when interest rate is given, we know the market rate is this, principal is this, future value is this. So then how many quarters will it take? I mean, how many years will it take? First, we find how many quarters, and then we can convert it into a. So all you need to do is simply, again, natural log of FV over P over natural log of 1 plus, 1 plus, and then it's going to give me 20. I found 20. And then how do we, you divide it by D26, which is, 4. That gives me 5 years. So we got it. We've done it. So this is how you find N. And next, we move on to multiple cash flow model. Now, multiple cash, so, I want you to watch the video, but you can do it later. What's important is that we do this exercise together while we are because I can, if you watch the video and it's all demonstrated in the video, but I don't think you actually do it, right? When you're just playing the video, and your mind is somewhere else, and you don't actually you don't do it with your hands, you don't have any hands-on experience. So I want you to do it while we are in the collaborate session. So now let's first not this one, think about what is the annuity. And it's simple. Annuity is regular deposit or regular payment made at regular interval. That's an annuity. The name is could be misleading because some people think some people associate with annual payment because it sounds, but no, it doesn't have to be annual only. It could it could be monthly, it could be weekly, it could be quarterly, it could be daily, but the idea is it has to be equal amount at equal interval or at regular interval. And hence it is called multiple cash flow model as opposed to single cash flow model. Now remember what we've been doing so far is a single cash flow model. Why? Because all these models were basically assuming that you make a deposit at time 0, right? Or if you make a deposit, then that's a cash outflow from you. It's a one-time cash outflow, and 5 years later, there will be a cash inflow of 30K. So only one-time cash flow. First, cash outflow, one-time cash outflow, single cash flow, and one-time cash inflow, a single cash flow. Hence, it's called single cash flow model, right? This could be, also this could be borrowing. I mean, rather than deposit, if you're borrowing 10,000, and 5 years later, that's cash inflow now at time 0, and at time 5, there will be a cash outflow of 30K, right? It's still a single cash flow model. Now, but then think about it. In reality, uh, suppose this was a loan. You got the loan, $10,000 loan today. But you know what kind of lender? What kind of lender waits for you for 5 years? What kind of lender waits 5 years for you to come up with this future value of 30K? Huh? If you think about it, there's no such lender. No lender, right, waits 5 years or 10 years. Look, even if you have excellent credit rating, right, uh, no lender lends you money for 10 years and just, forgets about it and waits 10 years and waiting for you to come up with, the future value in 10 years. That that's not the reality. I mean, uh, in reality, what happens is they want you to pay back in installment, right? They want you to pay back in installment. In other words, it will look like this. So suppose you borrowed, let's say, suppose you borrowed, 40,000. Suppose you borrowed, like this is more like it. Suppose you borrowed $20,000. $20,000. And the lender will want you to pay back $5,000 every year at the end of the year. Every year at the end of the year. Okay? So you might say, oh, why $5,000? Look, then that's going to be $25,000. Huh? I mean, didn't you borrow only 50,000, 20,000, not 25,000? Look, there's interest, right? Nobody will lend you without, so with this is the amount that where the with the interest built into it, right? So this type of, this is the reality. I mean, if you borrow money, you pay back in annuities. Okay. In this example, that was annual payment, but uh, most of the times it's going to be monthly, right? It's going to be monthly. So over 5 years, there's going to be 60 payments. But let's think about that's called that was the that model is called the present value of annuity because all the annuities happen in the future, right? But that doesn't mean they are all future value. In this case, what you need to what you need to know, what you want to know is what is the present value of all these annuities. Then think about it. What was the scenario? You borrowed 20K, right? You borrowed 20K. So if you're paying it over the next 5 years by annual payment of 5K, 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 the question is, what is the present value of that? And of course, the present value of that must be equal to 20K, right? Because otherwise, if it is greater than 20K, if the present value of all these 20K, present value of all these 5Ks, if the present value of that is greater than 20K, then this is a bad deal. You're paying more than what you actually owe. But in this diagram, it's actually the present value of all those 5Ks are only 18,954. It's almost 19K, only 19K. Then this is a good deal for you. You're paying actually less than what you owe. Of course, the monthly payment or annual payments would be all based on the I mean, it all depends on what is the discount rate. I mean, what is the interest rate being used for discounting? And if the prevailing rate in the market at the time was 10%, then using that, um, you get this. But I mean, when they are making a loan to you and they uh, uh, state what is the annual payment or monthly payment, then the discount rate is exactly the one that the number that will make it exactly equal to 20K, right? The discount rate will be, they will use the discount rate that will exactly equate the present values of all of these, that will make it equal to 20K, because no lender will get anything less than what they loaned out, right? No lender will uh, uh, knowingly and deliberately, knowingly accept any, installment payments, monthly or annual, that would whose present values will add up to something less than what they uh, uh, loaned out to you. So in this my scenario was just, I just randomly picked 20K, but if 10% is the correct discount rate, this is what you borrowed in today, right? And this is what they loaned out to you at time zero. And so with 10% discount rate, they will want you to pay 5,000, right, at the end of every year. Now that's called present value of annuity, because what we want to know is the present value of all these annuities that's going to happen in the future. But if there's present value of annuity, there is future value of annuity, and the concept is this, pretty much the same. But then our concern, what we are interested in, is the future value, not the present value. So, for example, if you are, suppose you are making a deposit, and you're making, $1,000 deposit at the end of each year, at the end of every year. Then 5 years later, if the prevailing market rate is 20%, 5 years later, what's going to be the future value of all these annuities? And then this diagram is, a very simplified example. Why? We have our timeline is very brief. Our timeline is very short. It's only 5 years, and you are making annual deposits. So there will be only five deposits, right? 5 payments or deposit. And I told you, in annuities, deposit and payment are the same thing. It's just two sides of the same coin. It's just two sides of the same coin, because if you are a borrower, you are making payment, right? And if you're the lender, there will be a deposit into your account at the end of every year. There will be a deposit of $1,000 into your account at the end of every year. So it's two sides of the same coin, right? So you're making these deposits, at the end of. So you have only 5 deposits that you will only, so you find, it's not difficult to find future values. This deposit will be compounded 4 times, because, you're making deposit at the end of the year. There will be 4 compoundings. This one will have 3 compoundings, right? This will be compounded 3 times. This one will 2 times. This one just once. And this one doesn't earn any interest. It doesn't get any, because this is technically considered deposit technically, but practically, you don't even have to make a deposit. You just, but this money has to anyway go into the bank. Even if it doesn't go into the bank, I mean, this will be your money, because at the end of year 5 you'll have all these future values, right? So if you just add them up, that's going to be this is the sum of all these numbers. That's going to be the future value of these annuities. Okay. Obviously, the simple sum of these deposits will be only 5,000. But with the interest accruing, this one, interest compounding 4 times, interest compounding 3 times, and so on. Sum of all these numbers will be much greater than uh, just simple sum of these, deposits. So, but think about it. The reality isn't this simple, because in reality, nobody, usually, it's going to be monthly payments or monthly deposit. If this was a borrowing, right? Um, if this was a borrowing, no lender will no lender will wait for annual deposits, annual payments. They will want you to make payments starting this month. So there will be actually it will be most likely monthly payments, monthly payments, and there's gonna be 60 months, right? You understand? There's gonna be 60 months, 60 payments, right? And our first payments will be compounded. So if the interest rate is 20%, monthly rate will be 20 divided by 12, whatever. It's going to be more than 1%, right? Greater than 1%. So whatever it may be, it's going to be 1.0 something raised to 59, because the first deposit is made at the end of the first month. So there will be all 59 compoundings, but there are 60 payments, 60 deposits. Why? Look, there are 5 deposits over 5 years. The last one doesn't earn any interest, right? So the last monthly deposit won't earn any interest. It will be just, uh, so if it is, you can do this when there are only 5 terms. You can do it like this when there are only 5 terms. But look, if there are 60 months, 60 terms, 60 payments, are you going to be able to do it like this? Huh? It will be a very tedious process. I mean, it's not undoable. It's going to be a very tedious process, because you'll have to raise it to 59. I mean, you have to have 60 uh, terms like this. The first one raised to 59, second one raised to 58, and all the way to raised to 0. I mean, this one, actually, you think, it is not, it doesn't have 1.2. Yeah, it is, it has like 1.2 raised to 0, right? Think about it. Anything raised to 0 is what? Anything raised to 0 is what?
0.
No. Anything raised to 0
One.
is what? 1, yeah. Who said 1?
G-Quan.
G-Quan, yes. G-Quan, you got, 0.25. Yeah, anything raised to 0 is 1. So think about it. 1,000 times 1.02 raised to 0, then it will be exactly 1,000, because, it's 1, right? But anyway, since you can't do, in reality, you have like 60 terms, there's no way you can do it like that. So we have to use, reduced form. And how was this reduced form? How did we arrive at this? That was explained. Look, it takes so much time, so I can't do everything in 2 hours. But that's why I gave you. Where is my? See here. Yes, it is here, right? If you watch this, I gave, I demonstrated the full process, step-by-step process, how, everything collapses to that formula. So please watch this. If you didn't watch it yesterday, watch it today, by the end of today, okay? And also, so this is the reduced form formula, right? So let's take a look at an example. to prepare for graduate school in 5 years, you save $800 every month. Suppose you are planning to go to graduate school. You want to do MBA. So first thing you have to do is you have to graduate with bachelor's, and let's say it will take 5 years. Why? You have to first finish BMCC, and that takes 2 years, right? Transfer to let's say to Baruch. I mean, why Baruch? You don't have to, but because CUNY is the most affordable school. I mean, if you do MBA in Ivy League schools, like or any private schools, Columbia, NYU, it would take at least annually $40,000 to $50,000. I mean, in very prestigious schools, it could take up to $60,000. But CUNY, it would be about half that. So an MBA program is 2-year program, so 60,000 will do. So that's this is just an assumption. It may be more. I don't know. CUNY, it's affordable. Zicklin School, check with Zicklin Business School, how much it will cost, but won't be more than $60K for 2 years. So an MBA program will cost $60K. So why 5 years? Just in case these days good MBA programs require also job experience. And job experience doesn't mean working at McDonald's. Okay, if you experience with a within corporate structure, like if you work for Apple, if you work for Google, in the corporate structure, or J.P. Morgan, Wall Street, even if you worked for McDonald's, but not flipping burgers, but in the corporate center, right? McDonald's corporate center, that experience will be useful, will serve you. But it might take 4 years, and if it takes 4 years for you to get your bachelor's, then maybe use one. And if you're lucky enough to land a job, 1 year, you can use that 1 year experience in a corporate center, corporate. Otherwise, let's say it takes you 5 years to, get your bachelor's. So anyway, your timeline is 5 years. The prevailing market rate is 6% currently, and your target future value, right? Our question is, and your payment, the rate, your timeline, so your N. Our question is, so this is actually, with $800 every month for 60 months, right? So N will be 60, and then R would be 0.5% because monthly, this will be 6% divided by 12, so 0.5% monthly. Those are all known. So how much is it gonna be at the end of 60 months? And so what is our question? Our question is this going to amount to is this going to be at least equal to 60K or greater? If it is greater, no problem. If it is less than 60K, we would have to think about saving more money every month. Okay, so this is a practical example, right, of anyway, future value of annuity. Another thing is, think about it. When we say multiple cash flow model, actually, annuity is not the only multiple cash flow model. Why? Annuity is a regular deposit regular or payment at regular interval. But and this is multiple cash flow because look, there are multiple cash flows, right? Multiple cash outflows, and at the end, just single cash inflow, right? And if you're the lender, if you're the borrower, um, I mean, making deposits, multiple cash outflows at the end, single cash inflow. So it's called, multiple cash flow model. But the multiple cash flow doesn't have to be always annuity. You can have, like uneven, at irregular interval, right? You can make, uneven deposits at irregular interval. It could be sporadic deposits, uneven amount deposited, sporadically. Again, in that case, the formula will be irregular. I mean, because every time the amount is different, but as long as you have like 5-year timeline or 10-year timeline, we can arrive at that. But every time the amount is different, and the interest rate may be different because in this case you're not locked. There's no the prevailing rate in the market will change every year, every month, but in this case you're locking into, because this is an annuity account, you're locking into this 6% APR. The APR won't, the interest rate for your account, this annuity account, won't fluctuate. It will be locked. Okay, so that's why we can, have this reduced form. If it is irregular, uneven amount at irregular interval, it will be, there won't be any, nice, unified formula. It will be all, random amount at random, interest rate and so on. So anyway, how do we handle this? So we know this is the formula, and one more thing we need to consider is that do we make deposits always at the end of the month or at the end of the year? No, it doesn't have to be. You can make a deposit or payment at the beginning of each month or each year. This diagram it has different, different payment, but and different interest rate, but the idea is the same. If you make this deposit or payment at the beginning of each period, how many compoundings will there be? There will be 5 compoundings because you're making it at the beginning. You're making this deposit at the beginning. The second one will have 4 compoundings. Third one, 3 compounding. Even the last one will earn interest once. Okay, so ignore the difference in the payment and ignore the difference in the interest rate. But the only difference, then what is the difference between the two? I mean, this is called annuity due, and this model is called ordinary annuity. Okay, so what is the difference between the annuity due and ordinary annuity? Can anybody tell me what's the difference between the two? Ignore the differences in these dollar amounts and interest rate. If you just simply consider that these are all $1,000 and the interest rate is all 20%, so it's the same, basically same scenario, same picture. I mean, same payment, same interest rate, same 5 years. But then what's the difference? Can anybody tell me what's the difference? Anyone? No? Nobody?
Wait, Professor, but it's each $1,000?
Yeah, just assume they are all $1,000 and all 20%. Ignore the, I didn't make, I just, got this, just took the, these pictures from internet, so they cannot be they come from all different examples. So I was lucky to find, same 5-year time frame. I've been telling you, ignore the differences in the dollar amount and interest rate. But if you ignore that, then they are the same thing,
Is it still a
right?
thousand?
Huh?
Because it's 1,000 times 20% times 5, right?
Yeah.
So it's 1,000 still. It equals 1,000
Yeah,
still.
yeah. It's 1,000 times 1.2,
Yeah.
1.2 raised to 5, not times 5, raised to 5. Okay. Second one, the first one is, becoming, raised to 5, fifth power. The second one is becoming fourth power, right? Raised to fourth power, third power. So what's the difference between the ordinary annuity and annuity due? No one can? No one? Look, it's very simple. The only difference between the two is one more compounding. Isn't it right? Annuity due has one more compounding than just one more compounding. Every term has one more compounding. Isn't it right? This one is raised to 4, but this is raised to 5, so one more compounding, one more compounding, one more compounding. Right? Even the last one has times 1.2, right? Every term has one more compounding. That's the difference. You understand? So we don't. So how do we? If this is the formula for ordinary annuity, what's the formula for annuity due? It is simply the same formula, but with just one more compounding there, right? With one more compounding. Look, therefore, future value of annuity due, right? Future value of annuity due is future value of ordinary annuity times 1 plus r. We can simply recycle. We can simply recycle the result of the ordinary annuity, and then give it just one more compounding.
Who's the other one you need?
Listen, please make sure that your microphone is muted unless you need to speak. Please make sure your microphone is muted, please. So, where was I? There you go. So let's take a look at the actual example, okay? Let's go to our multiple cash flow model, and let me blow up. And I told you to have this file in front of you. Do you have it all in front of you? I want you. So let's delete everything in the highlighted cells. Okay, let's delete everything. Also delete this one. So what do you see here? Also delete everything in the highlighted cells, please. Delete everything in the highlighted cells. Okay, and then what do you see here? Isn't this exactly our model that we just, talked about? Right? You're making an $800 deposit, and I told you deposit and payment are two sides of the same coin. So the name is, the label is payment, PMT, payment, right? So it can be, deposit, it can be payment, but it's unified. One unified symbol for that is payment. And the current market rate is, prevailing market rate is 6%. You have 5-year time frame, you have 5-year timeline. And because you're going to make monthly deposits, right? compounding frequency is 12. So the periodic rate, or in this case, the monthly rate, we know that already. It's simply APR divided by this, and N, actual number of compounding, which is 60, because 60 months, over 5 years, there will be 60 compounding over 5 years, right? There you go. Then using the formula, right? This formula, right? We can tell. Oh, okay. We can. So it's going to be payment times open parenthesis and open other one for 1 plus R, which is here, raised to 60 minus 1 divided by R. So everyone is okay. Everyone is okay up to this point. Okay, everyone is good up to this point. All right. We hit enter. Okay, hold on. We hit enter and we get this. Okay, what's your question?
I thought it was 1 plus R, not 1 minus R. Unless that's a different formula for something else.
No, 1 plus R. Okay?
Yeah, you have F2 minus R. I meant minus 1, sorry. Right?
Yeah. Because that's the formula. Payment times what? Open parenthesis 1 plus R raised to N minus 1.
Oh, okay.
R.
I was probably
Okay.
looking.
All right. So this is the okay, we got there. This is the future value of all these $800 annuities. Then and some people might say, "Yay, I got it." No, you didn't get it yet. Why? Why you haven't got it? Why you haven't got it yet? Now think about why we started this. Think about why we wanted to know the future value of all these $800 annuities. What was the reason? Does anybody remember why we wanted to know the future value of all these annuities? Does everyone remember? No one?
Oh, to see how much the money will grow, like the profit that you'll get after a certain time period?
No. What is the profit here? I mean, how would you know? I mean, what is the profit is, when you have income and if you subtract expenses from that, what remains after that? That's profit. And in this case, is there any expense? What profit are you talking about? So please think carefully, logically before saying it, because I've been telling you, people are just slaves to habit, right? You're just slave to your own speech habit. You understand? You just say, "Oh, profit," just without really analyzing what we are doing here. So there's no profit. I mean, what you can think about is, what is the total interest?
Is it the income for the year?
Say it again.
Is that the yearly
return of investment? Okay.
Return on investment? No, we're not. Return on investment is exactly 6% APR or 0.5%. This is the return, right? But that was given, you're earning 6% every year, but monthly 0.5.
It's the
right?
Is it the value of the future assessment? The 55,000? You're talking about the 55,000, right?
Yeah, but this is the future value of all these annuities. It's not assessment. What assessment are you talking about? Look, why did we do this? Why did we do this? What was the reason Huh? Why did we do this?
To find out how much you'll have after a certain time period with based on the interest. I mean the APR, sorry.
Look, look. No. I mean, of course, we want to find out, what would be the future. That, yeah, we did that. But why did we? What is our purpose? You forgot what the purpose is, huh? This is just the end result of, this is just the end result of all these $800 annuities, after 5 years, right? All 60 of them, with interest earned, it will end up here. This is just the end result. But why did we want to know this end result?
To make sure that we're putting the right amount in to come out so that we have enough for the tuition that we're saving up for.
Yes. Who said that?
Sophia.
Sophia, okay. Yeah, that's the reason behind it. We wanted to see if we can build up enough amount to pay for our graduate school. In other words, to pay for the tuition. I mean, 60K is it's not just the tuition. There will be other expenses, but add it all together. But let's say tuition, right? But we obviously, but then we can tell this is not enough, right? We're still falling about $4,000 short. We are still falling $4,000 short. Isn't that right? We're still falling 4,000. But at least we know how much, how close we are or how far away we are from our target future value. That 60K is our target future value, right? You understand? 60K is our target future. And we are falling short. We're about $4,000 short. So we can try different scenarios then. We can try, what if then we increase our monthly deposits to $850? Yeah, it will get us closer, definitely. But another thing, let's think about it. When you said, I just want to address this. When you said, how much profit we are making, maybe, just habitually you're saying that, but what you really meant was, so what is the interest that we earn over our principal? I mean, there's no one-time principal here. There's no one single principal here. But we know our principal is, there's no one-time principal, but our one-time, our total principal is basically total of this, sum of all these payments is our principal. Isn't that right? If you think about it. Because there's going to be 60 of them. Principal alone, payments alone. Some of all these payments is 48,000. 48,000, isn't that right? 800 times 60, it's going to be 48,000, right? You can consider that as principal. But there's no principal here, no single one-time principal, right? The principal is all spread out over 60 months, right? In $800. Small portions of $800. Make sense? So then we can tell what is the interest over total interest, because it's the difference between that 48K and this. You understand? The interest alone would be about $6,000, right? Total interest alone would be about $6,000. Anyway, this still falls short of our target future value target. So what's our another tactic? Another tactic is, or another tactic, another scenario could be increasing our payment to $850. Then let's think about it. It's not a big deal, we just, we can drag all of them down all at the same time, right? then this is the beauty of Excel, because you don't have to, we solved it once, you don't have to do it over again, right? It's the same formula, Oh, we are much closer, but still about $700 short. So we can, maybe, if we, increase it to 860, it might get us there. Or another scenario is, you can, if you can find a bank that pays 7% APR, that will, let's see, how's it gonna work? So we, and another scenario is, still 806%, but what if we postpone or lengthen or increase our timeline to 6 years? With 6 years, then probably that would be a lot easier to achieve our goal. So, and all you need to do is just copy and drag it down, and then with looks like, okay, 7%, 1% higher is going to help, but we're still about $3,000 or $2,800 short. Maybe if it is 8%, it might, but it's not going to be. It's not up to you. Think about it. If there's a bank that pays, is still short, we're still short. If there's a bank that pays 8%, that would be great. But it's not up to you. I mean, it's up to the bank, right? And the banking is a very competitive industry. Think about it. There is no bank that will pay superior rate than the going rate in the market, right? It may be 1 or 1.5% better, but it's not going to be like 2.5 or 3% better, right? So, but then what's under your control is this one and this one, isn't it right? You can make more deposits because if you work harder, if you work more hours, you can probably make more deposits. I mean, if this money comes out of your part-time job, and of course you have limitations. You have only 24 hours. You have to sleep at least 4 hours. At least 4 hours. You have to go to school. You have to study. You have to study for the exam. And maximum number of hours you can, but you work a part-time job, of 6 hours or 4 hours, I mean, if from working 4 hours or 6 hours, if you can set aside 850, maybe working 8 hours, you may be able to set aside 850. I mean, if you can set aside 800 from part-time job. If you work 2 more hours, maybe you can, or maybe this is under your control. Maybe if you increase it to 860, yeah, we hit the target. But we overshoot it slightly by $2. So this is not the exact amount. I mean, to make it exactly 60, it would have to be slightly less than this. And we can tell. We can nail it later. We can nail it, but we're gonna get to that later. So what about then? What about yeah? And this is under your control. I mean, you can So in this case, you make more than, you can save more than the target future value. And with an additional $9,000, you can probably buy yourself a very good computer, or buy a used car and move out to. You can move out to the suburb. Of course, if you're going to CUNY, then there's no place for parking, right? I mean, you can't park in the city, and it's going to cost you a lot of money. But you can move out to the suburb, where the rent is lower. It's just the commute. I mean, But anyway, we can find out like this. And also, what if it is annuity due? In case of annuity due, in case of annuity due, right? What did I tell you? Annuity due has just one more compounding. Annuity due has just one more compounding than ordinary annuity. So what do? You can simply recycle the result of the ordinary annuity. You just, multiply it by, you give it one more compounding. 1 plus R, if you use the ordinary annuity due, is closer, but still about $4,000 short. Okay, you are still, about $400 short. We can do annuity due. Next. So we know if we just save about $860 every month, but to nail the exact amount, it's not $860. It would be smaller than $860. How do we then nail that payment? We can nail the payment. How? Think about it. The target future value is known, isn't that right? The target future value is known, and then APR is known, so that means monthly rate is known, and N is known, which is simply this time this, and the unknown is payment. So we can solve that for payment. How? Look, I've been telling you over and over, I've been telling you so many times that no matter how complex any equation may look, as long as you can identify z equals x times structure, right? As long as you can identify z equals x times y structure, right? You can solve for x, or you can solve for y. Isn't that right? Remember that? And then, don't you see z equals x times y structure already here? This formula already lends itself to this structure. Right? Does everyone understand that? Can anyone tell? Yeah, okay. Can anyone tell me what is z, what is x, what is y in this equation, in this formula? Can anybody tell me?
FVA is
FVA. So don't stop there. You didn't say anything yet. You just said future value of annuity. And that's what? What is future value of annuity? Is it X? Is it Z?
Z.
So, okay, so what is Z?
FVA.
Future value of annuity.
FVA is Z, right? So give me the full sentence. Don't just say FVA. What is FVA? FVA is Z. Give me the full sentence. Okay, who gave me that?
Sophia.
Yanting.
Okay, Safia and who? Yanting?
Yeah.
Okay, you got 0.25, both of you. And then what is X then? What is X?
PMT is
Okay,
X.
Payment is the X. Okay, and who was that?
Yanting.
Yanting. Okay. And what is Y?
The rest is Y.
Everything else.
Yeah, the rest of them. The rest of them. Okay, that's Y. Okay. This thing is Y. So now we can solve for X, right? Okay. Okay, and was it Yanting again?
Yeah.
So you got 0.25 for that. Now solving for payment, it's then it's easy, you know. Payment is FVA divided by this thing, right? But then dividing, think about it. Dividing by a fraction is the same thing as
Multiplying.
Multiplying what?
The
Dividing
fraction.
by fractions. Huh?
The fraction.
Multiplying by the fraction? Just the fraction? You mean dividing by this is the same thing as multiplying by this again?
So multiplying by the inverse.
Yeah, multiplying by the inverse of that fraction. Okay, was that Safia?
Yes.
Okay, Safia, you got 0.25 for that. Yeah, I mean, this is not a difficult thing. Dividing by a fraction is the same thing as multiplying by the reciprocal, which is, you know, raised to -1. This raised to -1 is the reciprocal, which is, you know, simply then, I would say, multiplying by the reciprocal of the thing in the bracket, right? Reciprocal is the thing in the bracket raised to -1. Makes sense? So the thing in the bracket is this. So that is, you know, FVA times then the reciprocal is R over, right? 1 plus R raised to N. Yeah. 1 plus R raised to N minus 1. That's the reciprocal, right? The inverse, right? Look, so that's exactly this formula, right? In this formula, I didn't extend the outer bracket all the way up to this, but, you know, it's okay. It's the same thing. Why? Because when you multiply to a fraction anyway, it is multiplied only to the numerator. So it's the same thing. So we can nail the exact payment. So if, so solving for exact payment, solving for exact payment, FVA times R over, in parentheses, open another one, 1 plus R raised to N minus 1 and close parentheses. Are you doing all this? AC. Oh. Okay, I'm sweating like. Okay, if you are and all there, just hit enter. Now we got it. Look, yeah, when we entered 860, we overshot. We slightly overshot, right, by $2. We overshot the target slightly by $2. Now, so the difference wouldn't be that much. The difference is only like 3 cents, right? Every month, you know, 3 cents difference. 859, and you get this. Okay. Now, what is the next problem? Next problem is, okay, so we put this. We have 5-year timeline, and our target is 60K. So what should be the interest rate? How do we solve for this? Now, unlike single cash flow model, right? When it is annuity, there is no single unique formula for rate. So in the past, they used, what they call trial and error method. You take a guess, and try that number. And if it is not, if it is wrong, then you either increase or decrease. So in other words, if it overshoots, I mean, if you take a guess and like put 8% here, and if it overshoots, then obviously the range will. We know what the range would be. It would be something lower than 8%. We try the number, and if it undershoots significantly, we try a number that is greater. But then trial and error method is very obviously inefficient. It's called iterative. Also, it's called iterative method. I mean, you may eventually get it, you may eventually nail it, but then it may take forever. It may take forever, right? So obviously it's not an efficient thing. So how do we do? We use Excel's built-in function. We have to use Excel. I don't usually encourage people to use Excel's built-in function, but for rate in the excuse me, annuity problem, there's no other way. And the reason I don't like Excel's built-in function is it's like a black box. You don't, it's like a financial calculator. It's a financial calculator, but a financial calculator, you just punch in the number, you just input the data. You don't know what's going on inside, right? And that's what I really warn against, because you need to know the mechanism, right? If you know the mechanism, something goes wrong, you can fix it. But if you just rely on a financial calculator, you have a black box, you don't know what's going on, you don't know the mechanism, you just input the number, input the data, that's all. You are only feeding the data into the machine, and comes the output, but you don't know what's going on inside, right? You're not if that's the case, you're not a computer scientist or computer engineer, right? A computer scientist or computer engineer knows, the program, what's going on inside, the mechanism, right? So if something goes wrong, you can fix it. You can rewrite the program, or whatever. You can fix the program. But if you don't know the program, you just feed the data into it. You input the data. You're nothing but just data handler or data inputter or data, right? But I don't want that. I don't want you to be that. So that's why I don't want you to use Excel's built-in function. But for rate you have to. Normally when you click on that function, that fx, that's a function. That means function of x, right? And then usually it's the most recently used formulas, functions. So normally if you don't see it there, you need to go to the financial. And if you go to the financial, it's in alphabetical order. So you scroll down until you find rate, because rate is what you want. There's rate. So click on it, and you got to give it what it's asking for. Now n period, that's n period, right? And that's our n, right? If you don't know what that is, use your good sense. We've been doing this, n. What would that n be? What would that n mean? So you enter 16 there. You just click it in. Payment. You enter that. But here's the thing. You have to think about what is the cash inflow and what is the cash outflow, right? Because in financial calculator, you have to make a distinction between cash inflow and cash outflow. Cash inflow is positive. Cash outflow is expressed as negative number. It doesn't mean it's negative. It's cash leaving you. That's why it is no negative. In this scenario, this is the cash outflow, right? And 60K will be your cash. Actually, I would have to use, this. Let me start from the scratch because, we are in row 8, so row 8. N period here, there's N, right? And payment, this is the payment. But again, I told you this is cash outflow because that's what goes into the bank. That's what's leaving your pocket, leaving your wallet every month, and into the this annuity account. So that's cash outflow. You gotta express it as negative, right? You gotta express it as negative. And then there's no present value because this is not single cash flow model. There's no present value. There's present value only if it is a single cash flow model. So you leave it blank. Future value, we have target future value. There you go. We got something already here. But what's the next? What type? What does that mean? It's either that means whether it is annuity due or ordinary annuity. If it is ordinary annuity, you leave it blank or just enter 0 or leave it blank. If it is annuity due, you enter 1. And why do you think we enter 1 if it is annuity due? Anyone has the answer? Why enter 1 if it is annuity due? What's the logic behind it? What did we do with annuity due? What's the logic behind it? Anyone? Do you remember what we did here to, What did I say here? I mean, what's the difference between annuity due and ordinary annuity? What's the difference? Does anyone remember?
It's one less compounding.
No, one more compounding.
Sorry.
I mean, one more. Annuity due has one more compounding. Annuity due has one more compounding. Of course, ordinary annuity has one less compounding than annuity due, but annuity due has one more compounding. And so who said that? Who said one more compounding?
Sophia.
Sophia again. Okay, you got 0.25 for that. That's why we enter 1 if it is, annuity due. Okay, but if it is ordinary annuity, you leave it blank or enter 0. And unless otherwise instructed, unless otherwise specified, the default is ordinary. The default is ordinary. So, so there was no mention. There was no mention of annuity due or So we assume ordinary by default. So we don't put anything there. So that's it. Just we already see the result here. That's 0.005. That's 0.5%. So hit OK. You might wonder why is it 0? No, it's only the something wrong. And first of all, it shouldn't be here. I should have done it here. Actually, we should have. This is a mistake in highlighting. I should get it here, and also this should be that, and this should be. Because primary solution is, and this one also, right? Primary solution is, quarterly rate, I mean monthly rate, not the. So doing this all over again, rate. N, comma, payment. Okay. You make it minus. Nothing there, so comma again. Future value. Nothing there, nothing there. There you go. Okay. And why was it 0? Because this was like, you know, it was rounded, right? Rounding, right? But, you know, if think about it. If I did it here, it would have, you know. You have to give it always 2 decimal places by default, 2 to 3 decimal places. If you don't, then it just gets rounded, right? So 0.5 is monthly rate. So if we convert it into annual rate, all you need to do is what? This times monthly rate times, you know, 12. Yeah, monthly rate times 12. Then it should give you 6%. Okay, so we got that. We nailed it. Now, what do you think this is about? This, you know, scenario. It's the same scenario, but this time the unknown is n. So how do we solve for n? We have a formula for that. I thought I put it here, but you know, somehow, but it's here. It's here, right? In the slide. So here, you know, I gave both, you know, n formula for future value of annuity and present value of annuity. It looks a little, you know, complicated, but it's not a big deal. Again, we can use, you know, Excel's built-in function, but you know, it's better this way because you know that way you know the mechanism. So so we gotta find, you know, this is the primary solution, you know, how many months. So that will be natural log of future value over payment, and then times R. Okay, there's nothing here, but it will come. Since there was nothing here, it's not gonna. It will give you the +1. Wasn't it the formula? And then natural log of 1 plus R. It's blank now, but you know, I should have filled it in beforehand. Yes, that's the formula, right? So you hit enter, and of course it's not going to give you anything because you know there's nothing here. But what I'm going to do is I'm going to give it R. Then of course then we get 60. We must get 60. Everyone got 60 there. Everyone got 60. Then in years, of course, all you need to do is you divide the 60 months by 12. Then you get 5 years. Okay, so this is the how you find, you know, the future value of annuity and how to solve for other variables, right? Payment, R, N. Now, so let's move on to the present value of annuities. If there's future value of annuities, there's present value of annuities, right? So I'm gonna delete all of these. It should be 20K. All right. So what would be an example of, present value of annuities? So let's think about it. Quite often, the lottery is used as an example, but lottery is quite few. How often do you win lottery? Almost never. Few and far between. Not even few and far between. I mean, it's not like something that will only happen once in a lifetime, and to most people, it doesn't even happen at all in their lifetime. But it's a for pedagogical reason, a pedagogical ease, right? It's easy to more lottery example is used very often. More common example, more down to earth or more practical example would be like car financing, or even home mortgage loan. But let me start with the lottery example. Suppose you won $10 million lottery. If you win the lottery, you have two options. It's number two. It's not. You have two options. You can either choose to receive lump sum cash payout or choose to receive annuities. Okay? And if you choose cash lump sum, you get about 60%. Slightly more than 60%, but it's like 61% because the top tax rate is 39%. It doesn't go by your tax bracket. Because this is not your earned income. If you win lottery, it's not your earned income. It is what they call a windfall gain. In other words, you didn't earn it. It just by luck, by pure luck, you won a windfall gain. Okay, you got a windfall. So they tax at the top tax rate. The top tax rate is like 39%. Of course, in 2018, that was prior to 2018. In 2018, Donald Trump, tax brackets, Donald Trump lowered the tax rate, but that lowering doesn't mean it lowered every tax bracket. Actually, only the top tax bracket, and so it doesn't affect the top tax bracket is now like 35% or something like that. But it doesn't apply to most of us. About to 99% or 98% of the population. That top tax rate of 39% or 35% doesn't apply. So it was only a good thing for the top 1%, top 1 to 2% income level. But anyway, so 39% is almost 40. So if you choose cash, lump sum cash, then you get about 6 million. If you choose annuities, you get it over 29 years. 29, roughly that's 30 years. And suppose you get monthly. Let's say monthly you get 20,000. You get 20,000 every month for the next 30 years. Think about it. That's 360 months. 360 payments of 20K monthly. I'm happy with that. I'm fine with that. But if I ask, the question is, which one do you choose? Are you gonna choose annuity, or are you gonna choose lump sum? And then most people, without thinking, just say lump sum. And if I ask why, well, you never know. I may not be around, I may not be around, tomorrow. I may not be around, next year, next week, next month. Look, if you're so pessimistic about your life,
But wouldn't you take annuity because you'll get another compounding gain?
oh yeah. Listen, you can take annuity and you can save, or you can spend it. Even if you spend it every month, 20,000 is pretty, good money for monthly income, isn't that right? But no. Decision criteria is decision criteria is which one is greater. So how do you compare it? I mean, if you take lump sum, if you choose lump sum, you get 6 million today, which is in today present value already. It's today's 6 million. But then how do you compare if you choose annuity? There's going to be 20K spread over next 360 months, right? So some people might say, oh, then 20K times 360, that's going to be 7.2 million. So annuity is better. No, you can't compare it like that. Why? First of all, that 77.2 million is not the amount that exists at any single point in time, right? It's just simply multiplied it by 360. But think about it. That is 20K. I mean, that's 20K monthly spread over 360 months. So there's no 7.2 million in any single point in time. And to compare it like that, the 7.2 million must exist today. Then it's straightforward. I mean, 7.2 wins out. I mean, who wouldn't want 7.2 over, over 6 million, right? But then again, 7.2 million doesn't exist today. It doesn't exist at any single point in time, right? So it's like apples and oranges. You can't compare apples with oranges. So how do you then? Of course, we can then find the present value of all these 20K annuities. 20K is an annuity, isn't that right? Because you get it monthly. It's an equal amount. You get it at regular interval over 30 years. I mean, over 360 months. So it's an annuity. So we can find the present value of annuities. And that means, it's present value then. So you can compare it with the 6 million. Whichever is greater is present value and present value. Whichever is greater, you go for that. Okay? Not because you are pessimistic about your life expectancy. If you think, unless you're living a very reckless life, it's not likely people use life expectancy numbers, right? That means if you are like an average person, and you're taking care of yourself like an average person, eating, you're a health conscious eater like an average person. You drink moderately, you don't smoke, or even if you smoke moderately. I mean, what is the average life expectancy? If the average life expectancy is like 82 for a male, for average male in the U.S., then that's someone with an average, lifestyle is expected to live. Isn't it right? So unless you're deliberately leading a reckless lifestyle, you are normally expected to live up to 82, right? So then saying that I want to enjoy that money. Look, before something happens to me. Look, not because of that. That's not the rationale. That cannot be the rationale. The rationale, the reasoning behind it must be logical. And the logical reasoning is that when you compare present value with the present value, the 6 million is already present value, right? So and then find the present value of all those annuities. Whichever is greater, then you choose it. So how do you find the present? This is the formula, right? This is the formula. It's the reduced form. Again, another example is car financing. So we're out of time, so we cannot do the examples. But I'm already setting up the stage for tomorrow. So here, take a look at this. This example, look at the second row. This is 20K, which is your monthly payment, right? Annuity payment. APR 6%, 30 years. So we know we can calculate present value of all those annuities using the formula, right? And this one is the car financing example. We set it up. So we'll have to do this tomorrow because I guess if we can, and if we do that, then we can do the amortization. So our time is up. I'll have to call it a day. So take care of yourself, stay safe, and I will see you guys tomorrow. Okay? I'm gonna stop recording and sign out. All right? Nobody says goodbye, huh?
Goodbye.
You don't want to say goodbye. Take care, everyone. All right? Take care. I'm signing out. That's that. Okay.